Hello, I'm Emma Bayfield.
I'm Claudia Budden.
For our integrated catchment analysis modelling assignment, we looked at possible wind turbines locations for the South Island of New Zealand. New Zealand currently gets 80% of its electrical energy from renewable sources. Of that, 6% is from wind turbines. New Zealand currently has 19 wind turbines contributing to the grid. With lots of land throughout the South Island exposed to high winds, there's a chance to utilise it to make New Zealand electricity 100% renewable.
After some online research, it was found small wind turbines start rotating at 8 kilometres an hour, and to start to make energy, they have to rotate at 12.6 kilometres an hour. Because we want to ensure the wind turbines are efficiently making electricity, we assumed an appropriate wind speed would be 15 kilometres per hour. Wind turbines cannot work efficiently when the wind speed is above 54 kilometres an hour. Luckily, the mean wind speeds found did not breach this number, so no upper threshold was required. Wind turbines are massive pieces of machinery, so in order to allow easy access for installation, operation and maintenance, we made the assumption the slope has to be less than 30 degrees from the horizontal.
To make our map showing appropriate locations for the wind turbines, the model builder on ArcGIS was used. First, we found relevant maps for mean wind speed and South Island elevations. Next, the slope tool in spatial analysis was used to make slope values from the DEM. Because we are only interested in the 30 degrees and below slope, we used the reclassify tool in spatial analysis to make the above 30 degrees have a new value of no data and less than 30 degree slopes have a value of 1. Then the raster polygon tool in conversion tools was used to make the less than 30 degree slopes into a polygon.
Now the slope section was finished with, we moved on to the mean wind speeds. The wind speeds were reclassified using the same reclassify tool as before. This time, the greater than 15 km per hour was assigned to a new value of 1, and the below 15 km per hour was assigned to no data. Then, the raster polygon tool was used to make the greater than 15 km an hour wind speeds into a polygon. With two polygons, it was now possible to intersect them using the intersect tool in geoprocessing to get a final map layer showing where the wind turbines could be put.
The map on the left shows where the slopes are less than 30 degrees in the South Island. As you can see, most of the South Island has a slope less than 30 degrees, with mainly the southern Alps and other high country areas missing out. The map in the middle shows the final map of the slopes and wind speeds intersected. A lot of the land is not suitable due to the low wind speeds.
Areas in the South Island where there are currently wind turbines in the works correspond quite nicely with our map. The wind turbines in the Marlborough region are the same as ours, as well as some of the locations along the southern east coast. There is a large area on the southern west coast which is owned by the Department of Conservation, so it probably can't have wind turbines put on it due to all of the native bush.
The model we have constructed has some limitations. We use only the mean wind speeds, so the maximum and minimum speeds are unknown. This could be important because we want consistent wind speeds in the area used. The DEM for the South Island was also quite a large file, so every time we used a tool or moved the map, it took a long time to process. Wind turbines had many other factors involved in them, such as wind direction to maximise the generation of electricity, the size of the wind turbines, how many wind turbines are needed, and the landowners. Wind turbines are huge, so have a large impact on the amenity of the surrounding area. Some people may not be a big fan. Wind turbines are loud, which may annoy nearby landowners.
As great as our model is, there are some future improvements that could be made. Smaller files could be used so the processing time is smaller. Wind turbines themselves could do with some improvement to make them smaller and less noisy, so the community is not as affected by their existence. A smaller DEM could be used to have more precise slope values. Since ours was a 25 by 25, it would be beneficial to have a 10 by 10. Other factors such as wind direction, max and min speeds throughout the year for the wind, landowners, access routes, and transportation costs, size of wind turbines, and native land area could be looked into. In conclusion, overall, using wind turbines to generate electricity benefits New Zealand both economically and environmentally. Based on the model created, there are many locations in the South Island with a wind mean speed that is above 15 kilometres per hour and land slopes with less than 30 degrees, which could have wind turbines implemented. The model could be improved with further investigation into more specific areas considering elevation, land ownership, wind direction, community views, costs and access routes to remote areas. Thanks for listening to our presentation.